So this is a video on using less dictionaries in Python. And the reason for this is because of this pretty popular library that you might or might not know called Pydantic. And so what is Pydantic? Pydantic is a data validation and settings management using Python type annotations. And Pydantic also enforces type hints at runtime. So why would we want this? Let's just jump right into it then. So I'm just going to make a Python environment here. Activate it. Then let's call file item model. All right, so let's say that we want to make an inventory for a video game. So what will we need? We will need a class called item. And we actually need to import Pydantic, the base model from Pydantic. So from Pydantic base model. And I'm also going to import some typing stuff here. This is for type hints. So with an item, we need a name for the item that has a string, or that is a string, and we'll have an amount, which is an integer. And we also need the inventory, which will contain our items, and that'll be a dictionary of item slot placement, so like a number, but it'll be a string, and our item. And let's add one more class called item type, and this will define the type of item that the item is. We'll have a name, and then let's also make a tag called can trade, which is a bool. And so let's try to make an inventory with our new models. So let's have an item type called food type, and this will need a name. Food can trade is true. And let's start making our items. So item 1, say apple, and amount will be, let's have 150. And actually over here we need item type. So it's going to be item type. And we can put food type here. Item type is equal to food type. And let's have another item called banana. And let's have 50 of it. Same food type. And then let's make our inventory. Right, items dictionary of slot placement to item. And so let's run this, or let's actually print inventory and then run this. So what's it called again? Item model. So when we print our class here called inventory, it actually prints it in a readable format, which is pretty nice. Okay, so let's say we want to access item 2's food type, right? And see if we can trade it with another player or not. So how will we do this? We go to inventory.items, and you can see here that we have a hint, which is very handy, saying that it needs a string key, and what the string key will give back is a value of item type. So let's say we know this string key, which is 2. And now we can look into it and see what we have. So we can see that we do want the item type, right? So it'll be a type of item type, and we can type item type, and now we can see what it has as well. And we can see that it has name and can trade, and we want can trade. So now we can print this and see that our item 2 type is tradable. And this is where a dictionary differs from Pydantic, because Pydantic can give you type hinting, and it can also give you doc strings as well. So you can say like, this is a character's inventory. And then now when we try to create a new inventory, right? You can see that we have our doc string that we just created. And this is very good for documentation in terms of exploring methods and classes and whatnot, which is going to be very different from a dictionary where you cannot actually see what's going on in your data, right? So the dictionary version of this would actually be something like inventory equals, right? And then to access this item types can trade, what we have to do for dictionaries is that we will have to access the key. So like 1, but then now I don't have any type hinting, so I can't really see what's going on inside of the data, right? I would have to go and nest another key inside, which is like this, and I get nothing here. So I can't tell if I have name, amount, or item type in here. Like pretend that this is in a totally different area or a different file. Can't really see what's going on, right? Whereas here we can actually see the type hints and get everything that's inside of this item type or in items. So what else can Pydantic do? Pydantic can also convert into a dictionary as well, or use a dictionary to convert itself into the class itself. So what I mean by that is that, let's say we have this inventory here, right? Can I actually do it like that? Let's try it out. So let's say inventory 2 is equal to inventory, and then let's expand our dictionary that we just created here. And then let's print inventory 2 and get rid of this print. So let's run this. Inventory items. I think it's because it's missing this, right? Something like this, and then something like this. Yep, there we go. So it was just missing the key items, because in our inventory we have a key called items that maps to the dictionary itself. So yeah, you can use a dictionary to map it into a Pydantic based model itself as well. So it can actually convert back into a dictionary as well. So there's a dictionary method here that it can use, and we can see it in action here. And you can see that it is back into a dictionary, or it was converted to a base model and then went back into a dictionary. So what else can Pydantic do? Pydantic can also do a very easy way of handling validations within the class itself. We have an apple with an amount of 150, and let's say that we don't want it to be 150 and cap it out at 100. So how we do that is we can go to the item area, and we need to import validators. This validator, it's a decorator with a parameter with the key name. So I'm making it validate amount, and we do check amount limit, and it's going to be passing in a value. It's going to be passing in itself as a class and a value. This is actually a class method. And let's do a if value is greater than 100, it's going to raise a value error saying that it cannot have more than 100 amounts of an item, and not then return value. Let's try this again, and we can see that it hit our validation error where it says that you cannot have more than 100 amount of an item. And if we make apple like 99, then it will accept it and not hit the validation error. Another thing to note is that when it comes to integers, actually Pydantic will try to convert a string to an integer. So what that means is that, let's say that these amounts were actually strings, right? So like 6 and 8. So if we do this, it actually takes in, even though the hinting here, it says that, it'll give you a hint that there's an error, and it'll convert the string into an integer. So Pydantic is also used in FastAPI, which is a somewhat popular backend framework, or actually gaining popularity, I guess. Let's check out FastAPI here. We already forgot how to install it. So let's pip install and pip install this one too. Okay, so let's copy their example code, the py And let's make sure it works first. Let's run the app to see if it works. It's not main, so let's rename app to main. Run it, and see that we have hello world, so the app works. Okay, so let's make a fake database. It'll be a list, and let's make a post to /API/item/create. So we'll make an endpoint that can create items and insert it into this database. And to do that, let's import our item that we had earlier. So from item model, import item, name the function. And so here we can actually, what we can do here, right, is we can have it expect a request. What the request content should have is actually a dictionary, and that dictionary would automatically map to this item type and return it into this data. So when we do that, we can do database.append data.dictionary and then return database. So let's try this out. So let's check out our post or our post content. So this is what we're going to send to our endpoint that we just made. So let's run the app again. Yep, we'll bring up another terminal here, and we have our post JSON. We need our endpoint. So our endpoint is create 1000/create, and we'll need to post it, and we'll attach the JSON to it. And here that we can see we have successfully posted our data and got back this. And since this is actually still running, we can actually post more data to it, and we'll see that the database itself will actually be growing. So let's make this orange, make the amount like 40, and do the same thing. And we'll see here that our database has grown a bit because we are creating objects, inserting into it. And no, actually, let's show validations as well. So post and make the item 50, and same post. And here you'll see that Pydantic handles validations for FastAPI and gives back the correct response. It doesn't, it doesn't just crash the app and not give back or usually I think it would crash the app and then give back a 500 response, but in FastAPI, Pydantic actually handles the exception pretty well. And you can also obviously like customize everything about the exceptions as well. There's a lot more stuff that goes on in Pydantic that probably I don't even know about. This is just a very small snippet of what Pydantic can do. But yeah, that was just my small overview on Pydantic and FastAPI, I guess. If you guys want to learn more about Pydantic, I would definitely recommend checking out the docs. Yeah.